In this video, I'll talk about the how to perform or how to do the Hooke's law experiment. The first thing you need to do is download the PhET simulation, and you can download the spring mass simulation, which is from the PhET, by clicking onto this link here. Okay. After completing, then you need to answer all the questions and do the experiment. The first question is, what is Hooke's law? You already have studied about the Hooke's law. Write down what you know about the Hooke's law, and also you need to write down what is the formula for Hooke's law. Or in other words, what it's asking is, what is the relationship between the force and the displacement? Write down all the details, as much as details you can put in these questions. Now you have to set up. I just need to delete all these numbers here. Okay. Now you need to. Okay. Is there to its default value. So what it's asking here is you need to set up this way, and it says this: set the spring constant to the default value, which is the third line. What does that mean? So once you open the simulation, you will get to know. So first thing, when you open the simulation, let me open this one. You'll have the different the windows here. So go to the lab, go to this lab here, and this one has already a default, which is 1 2 3 line. That's the spring constant, and that's what it is asking here. Set the spring constant to its default value, which is the third line. And then the damping, it says the damping to none, so you can just slide this one to the none value. Okay, and then now you have to hang in the different masses and take the measurements. So let's do this one. The first thing, what I'm going to do, I'm just going to click onto this one, mass equilibrium and movable line. What does the mass equilibrium means? Let me show you here. Now you see the mass equilibrium means when there is no any hanging mass, this position is the mass equilibrium, and when you put a mass, this line moves. That's the movable. So this is the movable line, and this is the mass equilibrium. The black one is the mass equilibrium. That means when you have a mass and it comes to rest, then it will come to rest about this line. So now if I set the damping to lot damping, you see this mass has come to rest, and this is your reference line, and all the measurements has to be done from this reference line. So let's start with the zero mass. This is the 50 kilograms. So if I need to get the zero mass, there is no displacement. Okay, so with the 0 kilogram mass, there is no displacement, 0, and then you need to change this gram into the kilogram, which will again be 0. Then you have to change this mass to the force, which is the weight, and it says the formula mass times g. So this is again 0, so this entire row will be 0. Now let me show you with the 100 gram mass. So here now I'm hanging 100 gram mass, and you can change the value 96, 97, 100 gram mass. And now what is the damping here means? If there's no damping, then it will keep oscillating. For our case, it does not matter how much damping is, just to measure the Hooke's law. But when you're measuring the time period, then that matters. Okay. So now I'm going to set up the damping to a lot, just because I can measure this length here. So what is this length here? So this will again be an approximate value. So this value is now 20, 25, 26, 27, the 27 centimeter. So with 100 gram mass, the displacement is 27 centimeter. And you need to change this displacement to meter here. So you have to divide it by 100, which will be 0.27. And now coming to this row here, this is in gram, you need to change it to kilogram. How do you do that? You have to divide it by 1000, which will be 0.1. Once you have this kilogram mass, you need to multiply it by 9.8. If you multiply it by 9.8, you will get 0.98. So now this is your 4. Oh, just one second. I don't need this one, so just delete this one and delete this one. So this is 0.98. This is the force, and this is your displacement. These two row, the force, and this is your displacement. Okay, and now you have to keep doing for all the different values. So let's do one for 300. So how do I calculate for 300? You have to look at this, the black lines here. 300 now. So what is this mass now? 64. So you can see it's 64 now. So this displacement is 64 centimeter. So again, you have to change it to meter, which will be 0.64. You have to divide it by 100. So mass is 300 gram. You need to change it to kilogram, which will be 0.3. And then the weight will be 0.3 times 9.8. So if you do the calculation, what you get is 2.94. 2.94. So this is the force and the displacement, the table. Now once you have all the completed table, then you need to plot a graph between this force again and in the displacement, and which is in the, that's what it is asking here. If you do not know how to plot a graph, watch my other videos, and I'll post the link for the video as well. That will show you how to plot a graph between two variables in Excel. Okay. The next thing is, once you have a graph, then how do you plot, or how do you get the meaningful information out of it? In this case, how do you find out the slope, and what does the slope refer to? Let's say you have a line y equals to mx plus c. All of you might have studied about this in your math class. So if you plot a graph, this is a straight line, and the m is the slope. That's exactly the situation here. If you plot a graph between the force and the displacement, which is x, then you will get a slope here, and in this case the slope will be k. And what is k? That is a spring constant. So in this case, the slope of the line gives you the spring constant. Now now you have to repeat the experiment for the changing the value. Again, it says your spring constant value has to be exactly the same thing. Do not change it. It's the third line. And now this time you have to change to g equals to 15 meter per second square and do the repeat the experiment. So how do I change the g value? So you can slide in and then get to 15 meter per second square. That's it. And now you see now the displacement will change. Now you have to again change for measure for the different masses and fill out this table. So the idea of doing this is to see what is the effect of acceleration due to gravity on the spring constant. If you change the g value, which is acceleration due to gravity, will the spring constant will change? Just you have to answer that. Okay, I think this is it from this very simple experiment, and then make sure that you answer all these questions too. Okay, and write down your conclusion clearly. What did you see? How much is the spring constant value? What is the effect of acceleration due to gravity on the spring constants? So this is it. Again, if you have any questions, write down your questions in the comment section below, and do not forget to like, share and subscribe the channel. Thank you very much.